In the previous lesson, we learned how to graph trig functions and learn about their respective properties. And every time we learn a function in grade 11 and grade 12, what we usually do is transform them. So in this lesson, we're going to transform the sine and cosine functions. To be honest with you, you did the exact same thing as what we did here in grade 11, but except for the fact that in grade 11 we did it using degrees, and in grade 12 we're going to use radians. But to be honest with you, the ideas are exactly the same. So just a quick refresher. If you transform a sine function, it's going to look something like this. If you transform a cosine function, it's going to look something like this. So in both cases, you have the parameter a, k, d, and c. So we're going to quickly refresh our memory what a, k, d, and c gives us when we transform a trigonometric function, whether it's the sine function or the cosine function. And every time I teach this lesson, students always ask me the same thing. They ask me whether we're going to transform the tan function or the other four trig functions. And the answer is we can, but we don't. So let's see what A, K, D, and C have to offer here. So what does A tell us? A tells us the vertical stretch factor. Okay, you can say compression, but I'm just going to say vertical stretch factor. Okay, and what else does also tell us? A tells us if there is a reflection with respect to the x-axis. And lastly, because this is a trig function, we're transforming the sine function and the cosine function, A tells us the amplitude. A tells us the amplitude. So just a side note, the amplitude is half the distance between the maximum and minimum values. So if that is the definition of amplitude, then we have to put the absolute value bars. Half the distance between max and min values can't possibly be negative. It has to be positive. So even if A is negative, that simply tells me that there's a reflection with respect to the x-axis. It doesn't mean the amplitude is negative. Okay, so be careful. It's the absolute value of A is the amplitude, not just A. Okay, what about K? K tells us the horizontal stretch factor. And if there is a reflection with respect to the y-axis. Okay, so hopefully this is refreshing your memory. Now, specifically because we're working with the sine and the cosine function and we're transforming those guys, K can also give us a property of the trig function. So hopefully remember, K gives us the period. The period is equal to 2 pi over the absolute value of K. Okay, the period cannot be negative. Why can't the period be negative? Well, let's think about what the definition of the period is. The period is the horizontal length of one cycle. Okay, in simpler terms, how long does it take to complete one cycle, one repetition of the pattern? If that's what the period means, then the period can't possibly be negative. That's why we put the absolute value bars here. So 2 pi over the absolute value of K will give me the period of the transform sine or cosine function. Now last year you would have said 360 degrees, but like I said, we're working with radians now, so it's 2 pi over the absolute value of k. And this should make a lot of sense. Now, hopefully you remember this from last year, but if you are horizontally stretching, it's always going to be a factor of 1 over k. So if that's the case, your old period of 2 pi should be multiplied by 1 over the absolute value of k to determine the new period, because your stretch factor, your horizontal stretch factor, if you ignore the reflection, that's always going to be 1 over the absolute value of k. I'll try to make sense of this. You know what, let's do an example here just to help you make sense of this. If the k value was 2, let's do sine 2x. This 2 means that I'm horizontally stretching by a factor of half. Now you can also say horizontally compressing by a factor of 2, but I'm going to keep it as horizontally stretching by a factor of half. Horizontally stretching by a factor of half is basically saying multiplying your x values by half to get the new x values. Okay, so if you had a period of 2 pi, you multiply it by half, and now it becomes pi. So 2 pi times half is pi. So multiplying by the stretch factor to 2 pi will give you the new period. Okay, if you still don't understand why it's 2 pi over the absolute value of k, every time you see a transformed trig function, you should state the horizontal stretch factor, and you'll see that this makes perfect sense. Anyways, okay, D tells us the horizontal shift. The horizontal shift. Or you can say the phase shift. But in physics, phase shift means something else. That's why I'm going to use horizontal shift. Okay, D tells us the horizontal shift. It also tells us, because we're going to be graphing transform trig functions, I'm also going to say not only does it gives us the horizontal shift, it also gives us the beginning of our graph. Now, I use that term very loosely because you can argue any point to be the beginning of the cycle or of the graph, but it will make sense why I use the word beginning when we do the graphs. Okay. C tells us the vertical shift. And it also gives us the equation of the axis. So which is y equals c. Okay, so your vertical translation dictates where the middle of the wave is going to be. That makes perfect sense. The vertical translation will dictate where the middle of the wave will be. So originally, the middle of the wave used to be on the x-axis. So if you shift up or shift down, it will now be y equals c. I just want to make a side note here. For trig functions, when we transform trig functions, we usually don't reflect it with respect to the y-axis because we have these identities here. We know that cosine is an even function, so there's really no point in ever reflecting a cosine function with respect to the y-axis. Now, for sine, that's an odd function, so you can convert that reflection with respect to the y-axis to a reflection with respect to the x-axis. Okay, so in summary, that's what we said about A, K, D, and C. So each parameter gives us very important information, and we're going to use that to help us graph trig functions. All right. So, for example 1, we just learn how to extract information. So I want to determine the amplitude, period, and horizontal shift and vertical shift of each function. So let's do amplitude. So amplitude of f of x is a third. Amplitude of g of x is 2. And the amplitude of h of x is 9. Okay, so g of x, please don't say the amplitude is negative 2. It's a very common mistake. Amplitude cannot be negative. The next thing they ask of me is the period. So for f of x, the period is still 2 pi because I did not apply a horizontal stretch of anything. It's I guess you can argue a horizontal stretch factor by 1, which means the period remains as 2 pi. For question B, for g of x, the k value is 3, which means you horizontally stretched by a factor of 1 over 3. So the period should be a third of what it used to be. So you take 2 pi and multiply by a third, or 2 pi divided by 3, and you'll get 2 pi over 3. Ooh, so this one, be careful, k is not factored. So we're going to factor out k here, just on the top. So you factor out 3, so it's 5 pi over 21. Okay, so we're going to need that 5 pi over 21 later. But for now, the period is 2 pi over 3. For the same reason we said 2 pi over 3 for part B. Horizontal shift. So this is pi over 4 radians to the right. This is pi over 7 radians to the left. This is 5 pi over 21 to the left. Okay, so these are exact same things you learn about transformations in grade 11. I won't go over the big explanation of why this is right and why this is left. Vertical shift. This is 2 units up. This is 1 unit down. And this is 7 units up. Alright, so far so good. For example 2, they want me to write the equation of a sine function with the following properties and transformations. So let's just write f of x equals first. So if they tell me the amplitude of 5, what is this bullet really saying? That means the absolute value of a equals 5. Now if they told me that the period is 4 pi, well, if the period is 4 pi, that's basically telling me what the k value is. Okay, so we see on the first page that the period is 2 pi over the absolute value of k. The period is the absolute is 2 pi over the absolute value of k. So we can rearrange that equation. So if you think about it, this is 2 pi over the period, right? We just rearrange the equation on the first page here. So since the period is 4 pi, guess what? The k value is half. I'll have to erase this now. I'm out of room. Okay, so yeah, the absolute value of k is 1/2. And that makes sense, because if k is 1/2, you would say it's horizontally stretched by a factor of 2. So it goes from a period of 2 pi to a period of 4 pi. So half is giving me really good vibes here. I'm very confident this is correct. Okay, if I shift 3 units up, what is that saying? D is, not D, whoops, not D, C is 3, okay? And the last bullet, pi over 4 to the left, so that means D equals negative pi over 4. Sure, we'll give arrows here too. So each bullet actually told me one parameter. So 4 bullets give me all 4 parameters, and I'm ready to write the equation. So a is 5, or the absolute value of a is 5, and they told me to use sine instead of cosine. It's factored out. K is half, and we're going to the left. And 3 units up. So believe it or not, there are actually 4 possible answers you can write here. This is just one of the 4 answers. And I would argue this is the one that most students will think of. But there are 3 other answers. Because nothing is saying whether a is positive or negative. They told me that the amplitude of the function is 5. Okay, so that means the absolute value of a is equal to 5. They didn't say a must be positive. Okay, so I could create a reflection with respect to the x-axis, and I will still have an amplitude of 5. I will still have the same period. I'll still have that vertical shift and the same horizontal shift. So I can make the a value to be negative, and I can also make the k value to be negative. And these 4 properties or transformations will hold true. Okay, so if you make a negative and k positive, that gives you another equation. If you make k negative and a positive, that'll give you a 3rd equation. And if you make a and k negative, that'll give you your 4th equation. Okay, but I won't be that fancy. I'm just going to leave it as what we have here. They asked me for 1 equation anyways. All right, let's keep going. So they want me to develop the equation of a trig function which has a maximum point at pi over 3, 5, period of pi over 4, and a minimum value of negative 7. Okay, so first we should choose whether we should work with sine or cosine. Now because they gave me a maximum point, I'm going to use cosine. Okay, because cosine starts at a max. So when in doubt, if you're having trouble with this question, give yourself a diagram. And really, when I see this question, my head is thinking, okay, let's figure out the 4 parameters. Okay, we want a, k, d, c, and then we're done. Okay, so pi over 3, 5. Somewhere about there. Nothing I draw is to scale, of course. Okay, so I'm not going to draw the rest of the wave. I guess I could, but I can tell you what the amplitude is, okay? Because I have the maximum value and the minimum value of the function. So let's start off right here. Amplitude is max minus min over 2. So 5 minus negative 7 over 2, which is 6. Nice. What about the absolute value of k? Absolute value of k is 2 pi over the period, which is pi over 4. Now, before I do the math, let's think about it. Pi over 4, the period is pi over 4. It used to be 2 pi. So it was compressed by quite a bit. So in other words, you horizontally stretch by a factor of less than 1. If you do that, this is actually 8, which is good because if the k value, the absolute value of k is 8, that means you horizontally stretched by a factor of 1 over 8. And that makes sense because pi over 4 is an 1/8 of 2 pi. All right, everything's looking good so far. What about c? Where's the middle of the wave? If we have the maximum is 5 and the minimum is negative 7, how about we average those 2 numbers to find the middle, right? Average 5 and negative 7 will give me the middle. So let's write it over. Let's write it over here. C equals 5 plus negative 7 over 2. So you do the math, you get negative 1, which makes sense. If I have 5 and negative 7, negative 1 is most certainly the middle of my wave. Okay, so I have A, K, C, I just need D. Okay, so this is where we come back to what I said about the beginning. So if this is my beginning of my wave, I'm going to use that as my horizontal shift, right? I start here. I start at a maximum point of for my trig function. I could choose a lot of different points, but since it gave me this maximum point, I might as well use it. So therefore, f of x equals, okay, since I start at a maximum, okay, if I start at a maximum, that means there's no reflection with respect to the x-axis. So it's positive 6 positive 6 cosine, k is 8, and you shift it to the right because where did cosine used to have its maximum point? On the y-axis, right? But instead of being on the y-axis, the maximum point is now pi over 3 to the right. So you must have shifted pi over 3 to the right. To go from a maximum point here to maximum point here, you must have shifted pi over 3 to the right. So x minus pi over 3. And then since the equation of axis is y equals minus 1, then you must have shifted 1 unit down. You can even highlight that. Okay, so there's your equation. You can generate a different one. You can add a negative 8 here, or make the 8 here negative for k, because cosine is an even function, so adding that negative will do nothing. Okay. All right, so the last question here on the second page is to write down the key points for the sine function and the cosine function. So hopefully you already know this, because in the first part of our first lesson in this unit, we ask you to graph sine and cosine and know those graphs really, really well. So that will definitely be a good idea, because we're going to transform the sine and cosine function. We're not going to use that 1 over kx plus day plus c method. I'm just going to use the symmetry of the wave to graph the function, but nonetheless you should know the key points for the sine and cosine function. So we'll do sine first. So for sine x, okay, and of course we're in radians now, so it's 0, pi over 2, pi, 3 pi over 2, 2 pi, okay? And you need to remember, sine starts at the middle, or on the equation of the axis, reaches a maximum, goes back to the middle, down to a minimum, back to the middle. Okay, so I'll even draw it out, very quick sketch. Okay, you need to know that is sine. Okay, so those are 5 points right there. Knowing this basic shape for the sine function will help you tremendously when you graph. So what about cos x? So cos x starts at a maximum. Oh, that's very important to understand. Cos x starts at a maximum, and then it goes to minimum and then reaches back to the maximum to complete the wave. So cos x, you can also say may start at a minimum point, because if you apply the reflection across the x-axis, the cosine function will start at a minimum point. Okay, so be careful. Always remember that. You could start at a maximum or minimum point if you're cosine, but if you're sine, you must always start at the middle of the wave on the equation of the axis. And the regular sine function reaches a max and then a minimum. If you apply the reflection across the x-axis, it will reach a minimum and then a maximum. Okay, so I think we're ready to do some transformations now.